Hi everyone, my name is Eva, I'm an architect from Scotland and I'm phoning from Turkey.
Hi everyone, I'm Kseniia, I'm a geographer and researcher and I'm currently calling from St. Petersburg.
Hi everyone, my name's Nico, I'm an architect and I'm currently calling from London.
In 1947, an American architect, Oliver Lincoln Lundquist, working for the Office of Strategic Services, the CIA's predecessor during World War II, led the team to design the official United Nations emblem. The logo places the North Pole in the centre of the map. Its creation in the 1940s had a worldview shifting effect, a new understanding of the Arctic. The Arctic is a place that demands new planetary coalitions that extend outside of its immediate geography. Everyone has a stake in the Arctic. It is necessary for our stake to be mapped and thus governed. Through negotiation, coordination, and informed adaptation, new coalitions will be made. The site is the Arctic, and the geoprocess which it affects is the infrastructure that exert its influence on other sites. The exercise of interconnectedness reveals that the Arctic has the ability to radiate out with positive ecological and socio-economic effects. The message climate change media presents is one of Arctic shrinking, the fastest warming place on the planet. Ice caps retreat, sea ice dissipates, and permafrost burns. Summer Arctic sea ice is now predicted to be bare by 2035. No reduction in emissions is stopping it. But as the Arctic shrinks, the Arctic grows. It is now closer than ever to all of Earth's inhabitants. It grows through its felt interaction with territories spread far around the globe. Our planet has accidentally formed a megastructure in the form of planetary scale computation. The sensing layer forms a part of the megastructure, and through it we see with clarity our anthropogenic alterations on the scale of the planet. The sensing layer can be broken down into three categories: hardware, the physical sensing instruments; software, abstracted, simulated, and modelled data; and wetware, material surfaces which have the ability to be sensed. The majority of ecosystems are fully embedded into technospheric flows. 77% of land and 87% of marine environments have been altered by human activity. This project reframes ecosystems of planetary metabolism as now part of the technosphere. Governance is required of geoprocesses as if they are another kind of infrastructure, another technospheric flow. They are systems whereby humans are inherently entangled, and thus our comprehension is necessary to inform further entanglement. Tipping points are thresholds where a tiny change could push a system into a completely new state. A number of planetary tipping points have been identified. If triggered, the cumulative impact of these changes could cause fundamental parts of the Earth system to change dramatically and irreversibly. A domino-like cascade of melting ice, warming seas, shifting currents, and dying forests could tilt the Earth into a hothouse state, beyond which human efforts to reduce emissions will be increasingly futile. Many cascades originate in the polar regions. Arctic processes radically transform ecosystems that are far from its territory. Arctic ecosystem management can therefore drive the transformations of distant ecosystems. As it stands, the impact of regional decisions are felt far from the territories in which they have been made. This can be made evident by tracking the effects of melting ice in Greenland, which have been felt in the Sahel region of Africa. Such melting could induce a drastic decrease of West African monsoon precipitation and lead to the destabilization of the Sahelian agroecosystem. Similar cascading effects were apparent in February 2021 in lower latitudes, where cold air escaping from the polar vortex triggered extreme freezing. Another example of it was observed in Japan, where a prolific ocean effect snowstorm buried the region in snow. The disappearance of the Arctic Ocean's summer ice over the coming decades could destabilise distant economic engines, such as Panama Canal, as cargo ships are redirected via the Northern Sea route. In this sense, the Arctic is a system. It links territories through its changing dynamics and reaches locations beyond its immediate geography. Collective human action is required to steer the Earth system away from a potential threshold and stabilise it in a habitable interglacial-like state. Such action entails supervision of the entire Earth system, biosphere, climate, and societies. It could include decarbonisation of the global economy, enhancement of biosphere carbon sinks, implementation of human retreat, technological innovations, and transformed social values. As revealed here, there is a substantial body of Arctic scientific knowledge which stresses the importance of the Arctic processes in a much wider context. The regions which we have identified have a stake in the Arctic and therefore propose their active engagement with it, both in extending the territory's sensing infrastructure and as a space of intervention. The Arctic is a place for concentrated sensing, engineering, and planning strategies. If things are altered, they radiate out. This alludes to the necessary financial, technological, and citizenry involvement of other places along vectors of planetary metabolism. Global systems can never be altered with the knowledge of their full ramifications. Every material system has a temporal, ecological, and climatological set of relationships. To change any node in that network changes their relationships. In order to address one set of immediate circumstances, proposals are required, but in place are a set of sensing and feedback governance structures which have the ability to monitor and respond to new circumstances. A designed incompetence tolerance, a shift towards agile and reactive ecological governance, addressing what lies in our immediate future.